For many people, the effects of aging bring about both mental and physical decline. But is this decline inevitable? And does it follow the same progression in everyone? What role does environment and lifestyle play in this progression? Dr. William Greenough of the University of Illinois has been studying the effects of mental and physical activity on the structure and circuitry of the brain. The results of his research may have important implications for how we structure our physical and mental environments.
Some years ago, the conventional wisdom was that the brain developed. When it developed, it formed its connections. And once it was developed, it remained pretty much stable throughout most of adulthood until people began to age, and then maybe some of the connections were lost and maybe some of the nerve cells were actually lost. What we found more recently, by examining animals that grow up or are, as adults, placed in these enriched laboratory environments, is that the brain of the developing and the adult animal continues to be a very dynamic place. New synapses are forming, new blood vessels are forming. In general, the organization of the adult brain continues to reflect the history of that brain. It's as if in preparing for the future, the best way to do that is to adjust on the basis of what's happened in the past. Several years ago, we did experiments in which we housed animals in two different environments. One, which we called the enriched laboratory environment, had a group of rats in a large cage filled with toys, play objects, exploration objects that allowed for learning. The objects were changed every day so that the animals experienced a new environment each day. The contrast group, or control group, if you will, was a group of animals housed in a standard laboratory cage, just a clear plastic cage that allowed them to see out into the room. They were housed alone, no other rats in the cage. What we found with those two environments is that the animals in the complex or enriched environment developed nerve cells in various regions of cerebral cortex and other parts of the brain that had larger dendritic fields. That's the input side of the neuron. And those dendritic fields actually had more inputs, more connections from other nerve cells, so that the wiring diagram was actually embellished in those animals relative to the animals that lived in relatively impoverished cages.
These structures are called synapses, the minute gaps separating one nerve cell from another. These gaps are indeed the dynamic edge of the brain in action.
Another thing that we found is that the vascular supply, the blood system, was actually embellished in these animals. The animals had more capillaries. To really understand how important that is, you need to know that the brain more or less runs on empty. It can't store energy, carbohydrate or fat, in the way other parts of the body do. And so it's critically dependent, moment to moment, on the blood supply for its nutrients. And hence, if we tax the brain more, it adjusts in ways that allow it to respond to the peak level of demand it's likely to experience.
The results of Greenough's experiments were startling. Looking at one region of the brain, it was discovered that rats had developed more neural connections, a richer blood supply, and an increased number of supporting glial cells.
When we were doing the work with the enriched environments, we thought that everything sort of happened together, that it was one single orchestrated process. Nerve cells changed, blood vessels changed, and actually something I haven't spoken about, supportive glial cells all changed together. In order to examine this more closely, we did experiments where we separated out exercise from learning, so that we had one group of animals that learned motor skills where essentially they had to traverse an elevated obstacle course. These animals were learning, but they weren't getting a lot of exercise in the course of that experiment. By contrast, we had animals in exercise wheels that got a great deal of exercise, but had relatively little opportunity to learn. The somewhat surprising at the time result is that the animals that had the opportunity to exercise, and I should say these were adult animals, these were not developing animals, the animals that had the opportunity to exercise had a selective increase in the density of vasculature and no real change in number of connections. The animals that learned the obstacle course had a change in the number of connections, an increase in the number of connections. Again, the same general range that we talk about with the complex environment, 20 to 25%, and no change in the density of blood vessels. So what this shows is these are independent processes, and different demands placed on the brain will cause the brain either to change its wiring diagram to incorporate learning and memory, or change its blood supply to allow greater stamina to drive the muscles of the body. With regard to the implications for adult humans, we haven't really done those experiments yet. There are a few experiments that suggest that exercise can improve cognitive ability in sedentary humans, and that presumably is working through these kinds of mechanisms. But the one thing we can say is that the brain of a rat is very similar at the level of the individual nerve cells to the brain of a human. And what we see in rats, we really would expect to see equivalent effects in humans.
I think there's a lot of relationship between how you feel mentally and physically. I know I'm a lot happier and I can make better decisions if I exercise.
Just in swimming alone, if you don't come often, you lose it so fast. It's amazing, and it takes a long time to get it back. Any kind of exercise for that matter.
In mental alertness, I like to think that I've retained it, or that it's going to stay with me, and the physical exercise, I believe, has a lot to do with that, comes into play there.
There's one caution that needs to be mentioned, however, and that is that most humans are not like the rats in the impoverished cages. Most humans are, in fact, like the rats in the complex environment, or even are in more complex environments. And in fact, wild rats are also in more complex environments. So in a very real sense, while we're looking at how the brain responds and how it stores information, we're looking at what it does normally in the real environment compared to what it can't do in a very, very impoverished, almost prison-like environment.
So it may be that an active lifestyle, enriched with mental and physical stimulation throughout life, helps maintain a sharper edge for both brain and mind. The old adage, use it or lose it, seems to be supported for both humans and animals alike.
I've also continued to work, and I think that you do have to continue to either read or something to keep your mental alertness. But there's probably a certain amount of mental alertness that is maintained through the exercise.
I have climbed 97 peaks above 5,000 feet since I entered the old age category of 65. I am now 90 and a half. I never expected to last that long. I remember one elderly lady saying to me, "Why do you waste your strength climbing mountains?" I said, "I don't waste it. I gain strength." And then people will say to me, "Aren't you ever going to slow down?" I say, "What for? So old age can catch me?"
There's a saying, use it or lose it. And that goes for the brain. And I feel very strongly about that.